applies, if you want to know precisely
Oh,
what percent lies within 70%, in other words, if it's not an exact standard deviation, there's a formula that you can get on your calculator.
yeah. I have a form. Here, let me look for it.
And we're going to need that formula for the next question. Although
Yeah.
I'm not sure I know how to do the next question. What's that formula?
I have it. Oh wait, I think I got it right here. Oh, it's plus or minus 1 over square root n. See? Find the margin of error. Margin of error. Yeah.
N is the margin of error?
Yeah.
I don't really know how to do this problem. And I'm looking at a textbook right now that has a little bit of statistics in it and does not talk about margin of error.
Yeah. I can figure it out tomorrow in class.
Okay. Okay. Let's have you do that because I don't know how to do it. I am going to have to get a statistics book. You are the 4th student in the last month that has statistics problems. It seems like Colorado is working statistics much more into the curriculum because in 5 years of tutoring, I've maybe had, before this year, I had nobody, maybe one person had asked me about statistics.
Wow, yeah.
I don't have a textbook, so I guess this summer I'll have to get a statistics and probability textbook.
Yeah, we have like a couple, I think we have 2 sections over that kind of like go into it a little bit.
Well, I know the very basic statistics. I know this, the normal distribution, and I know sigma, and I know the mean, and how to work out the 68, 95, 99.7. But if you ask me what are the percentage of people to the left of 62%, I have no clue. And that's when you have to use a formula.
Yeah.
Which I don't have, but is actually on your calculator. I don't even know what the name of it is. I don't know how to pull it up.
Yeah, I'm not sure either.
Yeah, but there is a formula that'll tell you. In other words,
yeah, I'll have to figure that out tomorrow.
If it's not a perfect multiple of standard deviation. In other words, the first 2 problems they gave us were they were talking about 2 sigma. Well, we know what that means. And this one had a standard deviation of 2, so when we were looking between 6 and 10, we were looking between 3 standard deviations and 1 standard deviation. So we were able to use the 68, 95, 99.7 percentages. But figuring out how to do a 62% and a margin of error of 4.5%, we did not know how to do that.
Yeah.
Okay. So, is there any other questions you had for tonight?
I think I sent you 3 more questions, and it's just more trig.
Oh, okay. Let me open my email here. I closed everything out when my computer bombed. Okay. given the secants, it's important to know how to do this first problem. You want to be able to answer this regardless of the trig function they give you and regardless of the trig function they ask about. It's really pretty easy. The first thing you do is draw a triangle.
Yeah.
The second thing you do is label theta as one of the acute angles. Okay, once you've labeled theta, when they say the secant of theta is 8 over 3, help me dimension this triangle. Where's the 8? Where's the 3?
8's going to be the hypotenuse of theta.
Okay.
And 3 is going to be the opposite of theta.
Actually, that would make it the reciprocal of sine. Secant is the reciprocal of cosine. So
that is adjacent. Oh, my bad. Sorry about that. So it'd be, yeah, right there.
Right. So I can label that much of the triangle. Now I can figure out this side here. What's this side here going to be?
Let me figure it. It's going to be
the square root of the hypotenuse squared minus the other side squared.
Yeah.
So x,
Pythagorean theorem.
Right. And anytime you're solving a right triangle using the Pythagorean theorem, one of the sides is always the square root of something.
Okay.
If it's one of the two sides, then it's the square root of the hypotenuse squared minus the other side squared. And it's good to have this memorized. You have to solve so many right triangles in math that having to start from this is too much time. You want to know that C is the square root of A squared plus B squared, and you want to know that A or B is the square root of C squared minus the other side squared. So these two right here you want to kind of memorize, so that when you're given a right triangle like this, you can immediately go directly into this formula.
Okay.
So it's the square root of 8 squared minus 3 squared. That's 64 minus 9. It's the square root of 75. Excuse me. 64 minus 55. And that can be factored into square root of 11 times square root of 5, but that doesn't do you any good. So that's actually the simplified form.
Yep.
So now tell me what the tangent of theta is.
It's going to be square root 55 over 3.
And that's how you solve any problem like number 1. Okay? So let me give you one. The sine of theta equals 1/3. Tell me what the cosine of theta equals.
All right, 1 second. It's going to be 2 square root, I mean 4 square root 2.
Oh, you're right the
Or
first
2 square root 2, my bad. Over, what would it be? 3?
Yeah. In other words, because the sine of theta is 1/3, I can make that 1, I can make that 3. And then this becomes root 8, which is the same as 2 root 2. So the cosine is this divided by that.
All right.
Okay? All right. Let's look at number 2. A building is 50 feet high, and they're always perpendicular to the ground. At a distance away from the building, an observer notices the angle of elevation to the top of the building is 41 degrees. Pretty bad when I got to erase a straight line and redraw it. Okay, this is 41 degrees here. How far is the observer standing from the base of the building?
Just trying to figure out X or O.
So what equation can I set up, a trig function that will allow me to solve for x? Notice that I don't want to use sine or cosine because each of those relates to the hypotenuse.
Yeah.
What trig function relates 50 and x together?
Tangent.
So what equation can I write?
The tangent of 41 equals 50 over x.
Correct. Number you can get out of your calculator.
Right.
Okay. On number 3, what trig function can I use to solve for that x? Basically, number 3 is this.
Opposite. When you'd use sine of 60 equals x over 12.
Yeah, 1 second if you would. This is my next one.
All right. Yeah.
Hello? Yeah. Hi, Joe. Okay. Okay. Oh, no problem, Joe. That's fine. Well, we'll have to talk about that. There probably is a better way to work that. I don't know. Let me think about it. It might just be, yeah, it might just be better to wait until Dylan's out of school and then find out if I got a half an hour that I can squeeze him in on that day, and then that way we don't have that problem. Yeah, and you can always call me instead of making his appointments way in advance. That would probably work better. Okay. All right. Sorry, I'm in the middle of the session, so I got to run. Okay. Bye-bye. Bye-bye. I apologize, Alex.
Oh, you're good.
That was my next session canceling, so I wanted to
all right.
make sure I found it. Okay, so
Yeah.
what trig function allows us to solve for x in this model here?
Sine of 60 equals 12 over, or x over 12.
Okay, you got it. That's all.
Cool.
That's all it is finding the appropriate trig function to deal with the two numbers or the two values you have.
Yeah.
Okay?
Yeah, last time we went over quite a bit of trig, and the last quiz that I had on trig, I got a 90% on, so
Great.
I was pretty happy about that.
Trig is fun. I love trig. Trig is,
Yeah, I enjoy it now, too.
it's just all about memorization, really. If you have a good memory, you'll do good in trig.
Yeah.
But it's you kind of have to treat it like a new language. You don't really want to memorize trig functions. You want to know them like you know your name. You don't memorize your own name. You just know it. And that's kind of what you want to get to in a point of trig. You want to know that sine is the opposite over the hypotenuse. just immediately. You don't want to even have to think for a second on that.
Yeah.
So, well, good. Glad to hear that.
Mm-hmm.
Okay. Is there anything else you want to go over tonight?
No, I think I'm good for tonight. I haven't had that many new things yet, so.
Okay. I will see you next Wednesday.
Yeah.
We'll go back to 5:15. This was an unusual day.
All right, yeah, that sounds good.
Okay?
All right, thanks.
All right, Alex. Have a good one. Bye-bye.
Yeah, you too. Have a good night.